Okay, ladies and gentlemen. Applied force and tension. So, this is forces lesson 3. So, quick question for you, a review question for you. Would a bathroom scale work in space? So, would a bathroom scale work in space? Entirely good question. It's what we call a Gerdachen. Einstein called them a Gerdachen. That is a thought experiment because I'm not paying the, what is it, $50 million, $5 million a seat on the Soyuz space capsule to go up and check it out. So, bathroom scale. If I stood on this in space, would it work? Would it measure my mass? Yes?
No.
Why not?
Because it's like water.
It's like what?
It's like the water sometimes to train space astronauts are scaling water. It's not going to work.
Okay, I haven't seen that video. You have to find it on YouTube. Yes?
Isn't it because it's calibrated for mass gravity?
Yes. For this to work, we have force of gravity down, so this is measuring force normal up. The scale's measuring force normal. For that, we need force of gravity. What's the force of gravity in space? 0. So no, it doesn't work. Good. And this is to remind you, force of gravity is equal to an opposite force normal. Now, new stuff for you guys. Tension is pull, or force, through a rope or string or chain. So when I talk about tension, it's a pull through a chain or rope or string. Tension. So new definition. Yes?
Isn't that what the, like in our catapult project, it's like not the triangle shape, like the other, like sub thing for it? You remember what that was called?
Offhand, no. Sorry.
I know that the users mentioned like
Yeah. You wind up the rope at the bottom. Yes. The good old days, it was guts of animals, I believe. Anyway, now. So, too fast? All right. So tension. Now. So here you are. You've got your little baby brother on a sled. And you're pulling him along, force applied, 50 newtons. So what's his acceleration? You're pulling your little brother on the sled. Now notice this isn't a sled. I can't draw a sled. We really should be doing a free body diagram. Free body diagram. So there's your little brother. There's force of gravity, force normal, force applied. Now, have I said anything about friction? No. So in a sled, you're on snow and ice. How much friction do you have? Not a lot. So if I don't talk about it, normally we can assume there's none. So what else can I assume about this? Or what else do I know?
Gravity is 9.81.
Acceleration due to gravity is 9.81. So I can figure out mg. I can. Do I need to? Well, it's not hard. Mr. Calculator, punch the numbers in. But notice force of gravity and force normal are equal and opposite. He's not accelerating up. Your brother's not accelerating down. So these two forces cancel out. So your net force is the force applied. Now, what did Mr. Newton say about net force? I erased it off the board, but you could probably still see. Actually, you can still see it in the grind. Under conventional current, the green line. What does it say? You can just see it. MA. I got to wash those boards better. So can you guys rearrange this and tell me the acceleration of your little brother? Please tell me you can. All right, do it. 50 newtons equals 30 kilograms times acceleration. Acceleration is what? What you getting? 1.67 meters per second squared. Yep, works for me. All right. So far, so good? So remember the free body diagram. Now, better question for you guys. Get you up. Just waiting. Someone's actually copying out notes. So now, better question for you guys. You're out there hauling a trailer full of crap. This is 300 kilograms. Your truck is 1,400 kilograms. And you're applying a force 2,200 newtons. I want to know the acceleration of the trailer. Now, it's a bit sneaky, so I'll give you a moment to copy it out and look at it and think about it. Okay. Now, what do we know about the whole system? All right, let me rephrase that. The trailer hooked up to the truck, is it moving relative to the truck?
Yes.
Relative to the truck? No. You got a trailer. If it's moving relative to the trailer hitch, moving relative to the truck, your trailer hitch is screwed. You got bigger problems than how fast you're accelerating. Much bigger problems. Yeah, that gets expensive. All right. Now, if we look at this whole system, we can do a free body diagram for it. What does it look like? A dot. Force of gravity, force normal, force applied. Now notice I've said nothing about friction. Now here there's obviously friction, but since I haven't talked about it, we're ignoring it. Perhaps it would be better if I said F net. There we go, that's better. The net force is 2,200 newtons. That's implying there's friction, but we're ignoring it. We're just looking at the net or total of the forces, which is much easier. Now, once again, force of gravity is equal to an opposite force normal. So what's left? What's the only force left? The net force. And as Mr. Newton said, ma. So can you figure out the acceleration of this system? Or as he said, it'd be F net divided by mass. Now, what's the net force? The net force is 2,200 newtons. And the mass is 1,700. Mass total. 1,700 kilograms. 300 plus 1,400 is 1,700. No, I'm not going to do that calculation for you. Your physics 20. 1.3. So the acceleration. So my question was, what's the acceleration of the trailer? Well, like I said, is it moving relative to the truck? No. What's the truck accelerating at? So the acceleration of the trailer is the same, 1.3 meters per second squared. Now,
What do you mean you asked relative to the truck?
you got your trailer, you got your trailer, you got your truck. As you're driving down the road, is the trailer moving closer to the truck, moving farther away, or staying the same distance? Staying the same distance. Like I said, if it's moving closer, you got bigger problems. Either your trailer hitch is screwed or something's very wrong, and it's going to get very expensive soon.
So it's basically just saying if your trailer is moving faster than your truck.
Yes. And it shouldn't be. That's because it's tied to your truck. Yeah. Now, it really shouldn't be. Trust me. I've seen people do that and lose a trailer hitch or lose the trailer driving down the road. Not fun. Now, getting back to this, we know the acceleration. Now, that's a straightforward question. My question What's the tension there? Say it's chained. You're farming it up and it's a heavy-duty chain. What's the tension in the chain? No, it doesn't. You know exactly how to calculate it. Now, heads up, pens down for a sec, guys. I want to show you something. Heads up, pens down. When I say tension in the trailer, I am looking at this force here. So I have to look at one of the objects. So if I look at both of these objects, the force is in between and it cancels out. So, do I look at the trailer or do I look at the truck? What's easier? Trailer. Yes, the trailer is much easier because I've got tension, force gravity, force normal in the trailer. Force normal, force gravity cancel out. What's tension? It is the net force because it's the only force left, which is ma. Do I know the mass of the trailer? Do I know the acceleration of the trailer? Yes. Do it. Solve it. Tell me what the tension is, please. Sorry?
390.
Yeah, sounds right. 390 newtons
1.3.
times 300. Actually, I do MA, so I should say mass first. 300 kilograms. Okay, 390 newtons. Now, say Ethan was busy chatting and not paying attention to me, so he decided to do the truck, which is fine. How would I do the truck?
1,400 times 1.3?
Yes. The truck would be something like here's the truck. Force applied. Tension.
So then why is it easier?
Hang on. The truck, force of gravity, force normal. You've got the tension through the trailer slowing it down. You've got the force applied through the motor. Now here, the net force is 2,200. F net equals force applied plus tension. Now, note I'm going plus tension. Which way is the tension going? The other way. So some people would say minus tension. I prefer if you add it together and then realize tension is the negative in the opposite direction. This is MA equals 2,200 newtons plus tension. What's the mass of the truck? What's the acceleration of the truck? So 1,400 times 1.3 is? Sorry? Running out of space, I'm going to do it on a new page. And I do not like this new version. Where is the paste button?
Let's just tap on the
Right hand. Is that a new smartboard?
No, it's a new program. Paste. God, that's stupid. All right. Now, hang on. As I said, I ran out of space, so let's redo this. It's 1,400 kilograms. There's 1.3 meters per second squared equals 2,200 newtons plus tension. 1,400 times 1.3 is? 1,820 newtons equals 2,200 newtons. So how do I get rid of plus 2,200 newtons? Minus 2,200, minus 2,200, minus 380 newtons. What did I say the other way? I said minus 390. Okay. Is this 1.3333 repeating?
No, it's 129.
Okay. We're doing a little bit too much rounding off. That's why our answers are a smidge different. So on your calculator, don't go 1.3, go 1.29, yada, yada, yada. That'll make this 380 something, and it'll make the other one 380 something. They'll be equal. Yep. And there we go. There's our tension. There's the other way to do it. The hard way, because he wasn't paying attention to me.
So if you just do one calculation and
Yes.
You don't have to.
So what we're saying here is the tension is going this way, and it's 380 something newtons. This is going this way, the opposite direction. One's positive, one's negative, but they're both 380 something. So the minus sign is just in a direction. I don't care about that. You realize the trailer hitch, there's two forces acting on it. As long as you get the 380 or the 390, I'm happy. Okay? So that's net force. Okay, skip that. Okay. Evil, confusing one. All right. So, feel okay about that? Okay. The slightly confusing one. Mr. Sutton is in an elevator standing on a scale. Why?
Why would you?
Okay. Now, actually, let's get rid of the scale. It makes it too complicated. All right. Don't. Do not like this new version of the smart board. All right. There's Mr. Sutton standing there. Now, at rest, now notice I said I'm standing there. So what's happening to me?
You're not moving.
I'm not moving. So one, at rest, what are the forces acting on me?
Gravity.
There's going to be force of gravity. Now, I was going to say forces acting on me. I'd rather you think about the tension in the rope. Because I don't care about the force on me. I'm really worried about that rope holding me. Even though the only elevator route here is in the hospital and it's one story. Still.
I was just going to say, if you have a rope in the elevator, I wouldn't get on that rope.
No. So I am a wire rope, usually.
There's one in the arena.
There isn't, no.
There's one church.
Yeah,
They have an elevator.
yeah.
Oh, yeah, they've got about 50 steps leading up. Yeah, I can see that. Some of the old folks can have trouble with that, so yeah. Ooh, that must have been expensive.
You'll have to go through that.
Yeah, we should do that. I have to get my class 1 so I can go on a field trip there and we can do this. Now, if we're sitting there at rest. Oh, now, I know some of you guys watch the videos. Some of you guys are reading up on this or going to Khan Academy looking at YouTube. Looking at other videos, well, you're supposed to because Khan Academy in particular explains this stuff nicely. Sometimes they talk about force up or force normal. I prefer to think of this tension, but they could call it force up. Don't care. Now I want you to note here, if I'm not moving, F net is force of gravity plus tension, which is 0. Acceleration is because net force is 0. If I'm at rest, my velocity is 0. If my velocity is 0, my acceleration is 0. Yada, yada, yada. Now, can we figure out my force of gravity? Yes. I'm a smooth, slim 88 kilograms, so you can figure out force of... Be quiet. So you can figure out force of gravity and tension. Well, I should be specific. My acceleration is 0 because my velocity is 0. At rest, velocity is 0, acceleration is 0. Now, my favorite trick question for all of this. At constant velocity, what's my acceleration and my net force? If I have constant velocity, what's acceleration? 0. If acceleration is 0, what's the F net? In which case, force of gravity is equal to an opposite tension. So if I know what my mass is, I can figure out force of gravity and I can get tension. Blah, 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 blah. I like this at constant velocity because nobody pays attention to me when I say constant velocity. It's moving, there must be acceleration. No. Look at, now you can't see it in the grime anymore. But it used to be there. Newton's for, actually you can sort of see it. Yeah, you can sort of see it through the grime. I've got to clean those boards. All right. Anyway, Constant velocity, force of gravity is the tension. Now, more important. Okay. The elevator is accelerating up at 0.90 meters per second squared. What's happening? What's the tension? The tension in the cable. Now, tension, force gravity. Have I said anything about friction? No. So you assume there's none, which is a bad thing to assume, but for the moment, just shush. So F net equals the sum of the forces, force of gravity plus tension. Now, do we know what the net force is? Well, do we know the formula for it?
M times A.
MA. What's the formula for force of gravity? Force of gravity is always mg. Now, I did mention I'm still a slim 88 kilograms. Be quiet. So, do you know the mass? Yes. Do you know the acceleration? Do you know force of gravity? Yes, yes, yes. Can you figure out what tension is? And while I wake him up. All of a sudden everybody's head shoots up. All right, never mind. Now, plugging the numbers in here, can you guys tell me the net force, MA? Everybody grab your calculator and tell me what it is. 79.2 newtons. Now, what's my acceleration due to gravity? So what's my force of gravity? Force of gravity, mg.
862.
Now, which way is gravity going? Down. If I said this is going up, this is plus, so this must be minus. What was it? I'm sorry, Sydney?
863.28.
Call it 3 newtons. And I still don't know my tension. But can I solve for my tension here? Yes, I can. JJ is going to help me. How do I solve for T? What? I'm sorry? Yes. Louder. Plus 863.3 newtons to both sides. So the tension in this cable is what? 900 and? So, 3.1. Okay.
I got 942.5.
That's what I got, 942.5. Somebody's done some rounding off somewhere. All right, anyway, not that it really matters. It's something like, but notice what's the force of gravity acting on me? 860 something. What's the tension in the rope pulling me up? 900 and something. I weigh more because the elevator is being pushed up into my feet. So if I was standing on a scale, I would feel heavy. I would feel heavy on the scale. Would say I weigh more. You guys have all done the elevator rides. You know when it starts up, the elevator pushes into your feet. You feel heavier. So, Mr. Sutton is still slim, 88 kilograms, but he wants to feel lighter. So what can he do? Go down. Now, careful. When you say go down, what do you mean? The elevator goes down. Now, more specifically, I can go down at a constant velocity, or I can be accelerating down. Where will I feel lighter? Accelerating, because the elevator will be falling away from me. So, fourth one, accelerating down 1.2 meters per second squared. What's the tension in the rope? Mr. Sutton wants to feel light. So, what does Mr. Sutton feel like when the elevator is falling away from him? besides slightly scared.
Do you actually have a real fear ability?
Yeah, I fear most things. Yes, clowns, spiders, snakes, children. Well, some children. I have to be careful there because we're recording this. But how did Shrek? What was that comment from Shrek? Do not meddle in the affair of dragons, for your crunchy and tastes good with ketchup. Anyway.
I don't remember that.
Now.
I remember exactly.
Trying to remember, or maybe it was Smog from The Hobbit. Either way. Now.
It's either Shrek.
It's either Shrek or the Hobbit, you know.
One of those. All right, one of those lovely children's stories you stay up at night reading to your 3-year-old. Anyway. Now, help me out here, guys. Shh, I'm getting ahead of myself. I just did the free body diagram. You guys have to do that. Now, you also need the formula. What is the formula we're looking at here? More specifically, F net is the sum of the forces, which is?
M times
Okay, hang on. No, my apologies, Sydney. There's 2 versions of the formula. The version I'm trying to hit is? Yes, the sum of the forces. Now, you're right. The other way to write out the net force is MA, mg plus T. Now, I'm going to stop there and let you guys figure out MA, mg, and T. Now, I'm accelerating down. So, what is my acceleration? Minus or negative. So, what's the net force?
And we're still with the 88 kilograms?
Yes, I'm still the same slim 88 kilos. Yes?
You got negative 26.72.
Sorry? You got? I can't hear what you're saying.
Negative 26.
Okay, that's my what?
That's wrong.
Okay. There's not a lot of tension in that rope.
9.81?
Sorry, Sydney?
You keep it as a negative 9.81?
Yes. So this is 88 kilograms minus 1.2 meters per second squared. That's 100 and what newtons?
105.
Minus 105. 88 times, okay, guys, 88 times 1.2 is one number or the other. What is it? 105.6. All right. Mr. Sutton? Yes, ma'am. All right. So, Sydney, Ethan, get up there and finish that. Here, wear this so the camera follows you. And explain small words while I take time.
Okay. Small words. I got, yeah.
It's not an 8. Shit.
88 times negative 9.1, because that's gravity. And so a negative 863.
No, it's positive right now.
But you use negative 9.81.
Yeah. Oh, here, yeah.
Yeah, so then it makes it negative.
What is this? 88?
88 multiplied by negative 9.1 plus tension. And then 800, like this. Negative 863 point.
No, but it's positive here.
But
Should be-
this is multiplied with this so that it makes it negative. And then when you put it on this side, it'll be positive. 0.28. And then plus tension. So then you just do reverse, so you bring... Oh,
Never mind.
I'm trying to extend the page. Okay, so yeah, bring that over by adding it. So negative 105 point...
You should get a negative.
Hang on a second.
Plus-
Sydney? I'm going to say you made this minus, but it looks like the equal sign. So I'm going to change the color that it's minus 860. That works.
Okay.
If you have it right, it just looks like the equal sign. That confuses me.
Okay. 105.2 or 0.6? 2 or 6, Shannon? 105.6. Okay.
Wait a second. Why is this a 2 then?
Well, because Dean made a mistake. Okay. Plus 863.28. Okay, is 757.68 tension.
I'm confused now.
Okay, wait, yeah, because it's going down.
Yes, so you add 863 both sides. What do you get?
What is it?
757.68. That's
So-
757.
I don't. What?
68.
That's
What? Are you okay? Jesus.
Oh my
Ethan.
god. 7.5. What?
7.68.
0.7 is close enough.
Okay.
Now, notice the tension. That's up. What's the force of gravity acting on me? Down. 863. So, the force normal acting up on me is less, so I feel lighter. The elevator's falling away. All right. So, note there, if I fall down, or if the elevator's going away from me, I feel lighter. So, do I need to go on a diet? No. I need to hang out on elevators that are moving down, or accelerating down. Thank you very much. All right. Thank you. Now, so far so good? Yes, could you all stand up and stretch? Now. Okay. Certainly. All right, everybody stand up and stretch. There's a way to pause this.
Thank God you're not.